Okay, so it's been a minute since I made a video, but now I finally have something to make a video about, which is cool. Also, entirely unrelated, but new computer. Hopefully the last one I'll need for a long, long time. This is a P53 ThinkPad. I'm not sure how old it is, probably 4 or 5 years, but it has a 4 gig NVIDIA card in it, which is cool, and it's expandable to 64, 128 gigs of RAM. I have 48 in it right now, which with these RAM prices, worth more than the computer. But yeah, it's awesome. I love it. No complaints. It is huge and heavy, but it's got a GPU in it, and its cooling is very effective and also quite loud. But anyway, so my impetus for building this is kind of two parts. One, I wanted to do a kind of simpler, cheaper version of something I want to do on a much larger scale at work, which we'll get into in a minute, which would be very, very expensive. And I also wanted to see the feasibility of locally hosted LLMs for my work, which is, I'm really just using them for coding assistance and very minor code generation. I don't use like agentic AI or anything like that. I don't give AI access to my code bases and all of that wild stuff that some people are doing. At least not yet, but I don't have any need to, so I don't have a real desire to learn how to do that stuff right now. I have a lot of organizational data at work that must stay on LAN. Cloud hosting is not feasible. Exposing that stuff to an LLM is off the table, which isn't really up to me, but I mean, that's fine. I understand the security posture. The end goal is to take a reasonably sized model, tune it with RAG or something similar, and create a customer facing, basically a chat bot where people can interact and ask questions of data that's been fed into the model, mostly like infrastructure data, utility, electricity and other commodity consumption data, and a lot of other things. So, and I had a feeling that this would work. But I didn't, it's hard for me to ask for 5 figures worth of money to build a new server that would be able to do this without showing a much smaller, simpler working version, right? Because I can't just say, give me 10 grand or 20 grand. By the way, I don't know if this is exactly going to work the way that we want, because there's just this world of tuning and models and stuff is new, and it changes daily, and there's just 1,000 different configurations that you can have. And I'm not an AI or ML expert, beyond using Claude and Chat GPT. So I wanted to be able to confidently say, yes, if you give me money, I'll be able to build this. I'll be able to deliver this precise product as it's, being described in this proposal effectively. So that's where it started. And, my personal usage was kind of secondary to that, because this is, a little bit more interesting, but also more directly related to, making myself valuable at work and providing valuable tools for my department, which comprises almost 400 people to use. But that's a whole other thing. My job is kind of wonky when it comes to computer science and coding and dev and all that stuff. But that's a video for maybe another time when other people actually give a shit. So in the process of trying to get some kind of validation as to whether this vague idea I had in my head was feasible or doable, or if someone else had done it, watched a lot of YouTube videos, asked GPT a lot of questions. It probably got irritated with me if it's capable of doing so. And I found some interesting data, or lack of information, I should say. There are a lot of people with home labs, obviously. They're almost a joke, a meme at this point, especially with how much money they sink into stuff. And there's a lot of people doing locally hosted LLMs for obvious reasons. And there are a lot of people building multi-GPU clusters for really big models. Across all those people, most of the people getting into the nitty-gritty with specs and performance are people like home labbing. They're spending less than $2 or $3 grand on some type of GPU addition or setup to their current home lab. And those I got the most use out of. But those kind of fell short for me because a lot of them were not clusters. They're not using Olama or whatever to spread a model across GPUs, which is kind of the crux of my question, is whether that's possible. And what I also found is that among the people building multi-GPU rigs with consumer cards for like video gaming, 4090s, 5090s, that kind of stuff, and spending 4 or sometimes 5 figures, $5 grand plus, not a lot of them talk about performance with respect to like tokens per second, how long is prompt eval taking them, and stuff like that, which I found interesting and also odd. Expect if you're going to go through the effort of being a YouTube content creator, building these things and making a video about testing it, I don't know why you wouldn't include that unless it was dismal, or unless I don't know beyond that. That's the only theory I have. So all of that to say, YouTube wasn't super duper helpful when it comes to GPU clusters and spreading models across them. But at the end of the day, I figured I was pretty confident that Olama would be able to spread a model across various GPUs, or multiple GPUs, I should say. And I figured that if I bought a server and it couldn't handle, I couldn't for whatever reason spread a larger model across GPUs. At the end of the day, I would still have at least a GPU that can run one model, and a server that can, beyond LLM hosting, do basically anything that I want to. So it kind of negates or eliminates any need for any other kind of testing computer or other setup, because I've made videos in the past tinkering with Raspberry Pi Picos, Raspberry Pi 4s. I built a stupid Beowulf cluster out of 1 liter Lenovo Think Centers, which was fun. Now I really have no need for, it'll be more compute than I ever need at the end of the day. So as far as the hardware setup, I ended up going with, this server is on the small side. It's not the standard width. And I think it's perhaps 2 or 3U in height. So it fits a full-size card, long ways as they typically sit in servers. There's dual socket, and it came with 32 gigs of RAM or something like that, but also dual 1400 watt power supplies, which I like. I only use one most of the time, just long story, but I do. And that's what it came with. So it came with a 6 or 8 core Xeons. I upgraded them to 18 cores each at 3.1 gigahertz for a total of 36 cores, more than I'll ever need, but good for Proxmox and VMs and stuff. I upgraded the RAM from 32 to 64 gigs with some extra sticks I had around at work. And I bought one NVIDIA Tesla P100, which is an old data center centric card, so it has no IO other than PCIe. And it's passively cooled. So I started with one. I got a 14B model to run on that, and I said, cool, let's buy another, because the server has 4 or 6 full-length PCI lanes. I was like, let's do 2. 2 is probably good. 3, it's gonna get too hot and cramped in there, and I'll get into cooling in a minute. So that's what I ended up with. 2 cards that are 16 gigs of VRAM each. They have 3 or 5,000-ish CUDA cores, no tensor cores, because I believe is the last generation of cards, data center cards that NVIDIA made that did not have tensor cores. So that being said, they're $100 a piece, actually about $90 a piece, and it's hard. I don't think you can get that kind of performance anywhere else. That is the best bargain right now. Because NVIDIA made other Tesla data center cards that had more VRAM, but they had fewer CUDA cores and things like that. And they also obviously made cards since then. I don't know how old these cards are, 5, 6, 7 years old. They were probably a couple of grand, 5, 10 grand when they were new. But as far as value for VRAM, I think it's unbeatable. Because even a gaming card that has 8 or 16 gigs is gonna cost you between $300 and $700. 24 gigs, forget about it, 2 grand probably. So at the end of the day, out the door with because the additional RAM was free, with the new CPUs, the server, and the 2 cards is about $600, $650. And obviously, since it is a true server, it has fans everywhere that are incredibly loud, and these cards are passively cooled, so they needed to be in a server as opposed to like a regular desktop tower or something like that. But that became a whole other thing. As far as software, I'm extremely familiar with Proxmox because I use it. All of my production VMs at work are on Proxmox. Actually, everything I do is on Proxmox, now that I think about it, which usually houses Ubuntu server VMs. But anyway, so I went with that for an OS. So I made it, and then I made an Ubuntu desktop VM, and I did full pass-through for both PCIe lanes for both GPUs, so that Olama could see and use both of them completely. And then I installed Olama, and I made it a system CTL service, so it runs all the time. And it's very, very easy to use that way, 0 complaints. And then I downloaded and Dockerized OpenWebUI, which is just basically a ChatGPT clone for web-based UI. So it looks just like it. You can upload a file to your model. You can toggle between models very easily. It has a giant hideable, not a nav bar, but like a settings tab, I guess, where you can change everything you can ever imagine about a given model. It's pretty cool. I like it a lot. No complaints with that either. And I have that exposed on some random port so that I can, rather than doing SSHing into the VM and then doing everything from CLI, which is okay, but if you want to do it for stuff like code or give it a PDF or some other kind of data, it's kind of a hassle. If it's possible at all from CLI, I'm not sure. So OpenWebUI makes it, in a sense, it makes it exactly like ChatGPT as far as usability and user interface. Super cool. But all of that is like very easy to boot up and get going from a cold start. OpenWebUI in Docker does take, a few minutes to get fully healthy and usable, but that's okay with me. I'm never like in a rush to boot it, so it's not really a big deal. Most of the impetus for putting it in a VM was because I didn't want to tie up an entire server with LLM fiddling. I want to be able to turn it off and do other things, which might also need the GPUs or might not need the GPUs at all. Some other harebrained idea I get at some point in the near future. And I didn't want to tie up resources or anything else. And I just, it's Docker and VMs is just kind of my knee-jerk reaction in DevOps and software development. So it seemed like it just made sense. And I just, allocated it some disk space and some RAM and called it a day, and I can just turn it off, and those, I don't have to worry about those GPUs or, system utilization or anything like that. So after I got the second card in and got the PCI pass-through sorted out, which took a minute, but it's pretty straightforward after the fact, looking back, which is really just a selection when you're in Proxmox and you're looking at a VM and you're configuring it for the hardware and the software and the networking and all this other crap, boot disk size, whatever. Pretty straightforward. And I had no problem with NVIDIA drivers. I downloaded one and it worked perfectly, so I have no problem using any of the driver utilization, NVIDIA SMI, and all of this other stuff, seeing temps, power usage, memory usage, etc. So I tried a lot of models. Obviously I had 32 gigs of VRAM and I didn't know any better. So I immediately went for a 32 billion model, which, you know, was something like 30 gigs in VRAM. I mean, that was just awful. Then I changed a lot of things, context sizes, all of these other things that I, you know, wasn't really sure what it was. I was just trying to shoot in the dark and see if I can get some kind of performance increase and kind of get my footing in the self-hosted model world. But I could not get 32 to work very well. It just, I guess the context was just filling up too quickly, and then just the fact that you know, my PCI lanes are Gen 3 because this server is from 2014. Oof, I got married in 2014. That's almost 12 years ago. So then I backed it back down and I said, well, let's turn one GPU off because Olama makes it very easy to do that. Let's ignore this one and let's try, you know, a 7, 10, 14 billion model on a single card. And that was fine. That was great. You know, 50 to 80 tokens per second, blazing fast. And I was like, well, that's cool, but I have these two cards and I really want to sort it out. So I kind of went back to the drawing board and just gave it default parameters and left the context window the default, you know, 4096 or whatever it is, 4 grand and change. I upped the fan speed because they were getting kind of hot, and that seemed to do the trick. Like in a single conversation with one prompt after another, and granted they're not super complicated prompts, they're not complex, they're not long or verbose. I'm not including documentation with it. I'm just saying, explain this and then tell me about this and then what is this type stuff. Not a whole lot of reasoning going on, admittedly. A 30B model spread across both the GPUs seemed to work quite well. It maintained 40 to 50 tokens per second, which for me is totally fine. I would say that's pretty similar to ChatGPT's UI. Maybe it's generating it faster on the back end and just slowing it down for whatever reason for users, but I mean, it's pretty zippy. Like I can't read as fast as it's spitting out, which if you can't read that fast, then why does it need to be any faster? You know what I mean? Assuming you're reading all of it, I guess. So I settled on 30B. The fastest one I found was ChatGPT OSS 30B, which is cool. But like I said, cooling ended up being a problem. I initially bought a shroud that includes a fan, a server fan, that connects directly to a GPU, because I took both of the plastic top half covers off the GPUs because they were taking up space and the lanes are so close together that I wanted to, you know, at least a centimeter between them for air to get through. But it was incredibly loud, somehow louder than the server fans that are already in there, of which there are 5, including the CPU fans. So, and it was blocking airflow to the other GPU and to other components. And I was like, this isn't working, too loud. So I took it out. And at that point I was limited to just BIOS fan settings, which I have no idea what the units are, but it gave me a range from 80 to 250. I started out at 80, that was not good enough. The cards were getting throttled after considerable use, and they were taking a long time to cool back down to about 45 to 55 as an idle temp, which I would still like to have lower, but we can get into that in a minute. Then I amped it up to 90, 100, 120, 150, and I was like, oh, let's push it. So I ended up settling for 190. So as you can imagine, this thing is screaming loud all of the time because it's not doing dynamic temperature-based fans. It's constant at that RPM, whatever it might be, 5,000 or 6,000 or something, which is going to be a long-term problem because right now I have yet to move this server while building it out to the data center on site, which is freezing cold. Right now it lives in my coworker's storage closet, which he isn't in frequently, but when he is, he can hardly work. So I generally have to turn it off while he's sitting there so that I don't feel like too much of a jerk. So that's a whole other thing. But right now, with that cooling, just using server fans, it's acceptable. And they cool down relatively quickly. You know, they start throttling at, I believe, 80C. And if I hit 80C and then I I turn off Olama and I stop, I unload a model, it takes, I don't know, maybe 5 to 10 minutes before they're back to baseline, which is kind of long, but they're giant hunks of metal, and the heat sinks run the entire length of the card, right? So there's a lot of metal there to cool back down. So it could be better, and that'll be mediated if and when either this server gets moved to the data center or we build a new one, in which case it will immediately live in the data center, and that'll be a non-issue. So cooling did end up being a problem. I wasn't certain that it would be to begin with, but I found a command that told you whether or not, explicitly, if it was being throttled, and it was. And I was like, well, okay, that makes sense. So let's maybe back off of it. And I also found that, interestingly, if I ran a 14 billion parameter model on a single card, it would get hot really quickly. But if I spread one out across both, even though they're both full, they both seem to get hot less quickly. I don't know if maybe I just goofed something and that's incorrect. It doesn't make a lot of sense to me, but that's what appeared to happen, which is odd. So beyond cooling as a bottleneck, I think the other large bottleneck is obviously the lack of tensor cores, which I can't do anything about in these cards. I could get the next newest card that NVIDIA made after that, which was the V100, which has tensor cores, but it cost $395 on the used market versus the 100 that I paid for each of these cards. And those are still only 16 gigs. And so whether or not, this setup as it currently exists in its iteration, I'm not dumping any more money into, because this is all personal money, right? And for a production server, well, that would really depend on how much money I had to work with. Although that being said, most of it would probably have to go to cards. But beyond that bottleneck, cooling was also a bottleneck, which is relatively easily remedied, assuming the server lives in an appropriate place, not someone's storage room. The fact that the PCI lanes are Gen 3 and not Gen 4 or 5 apparently is a contributing factor. To what degree is hard to say, maybe 10 to 20%, but even still, that would be nice to claw back. I guess beyond this, my next step is to do some tuning of some kind, which seems to be a whole other world beyond training, so that I can figure out what kind of format data needs to be in, which is apparently very particular for models based on how you want to query it and what kind of responses you want to get back. So that's going to be a pretty big effort, because I have a lot of data to do that with. Most of it will probably end up in CSVs. I know nothing about tuning and RAG and all this other stuff. So that's going to be a whole other undertaking. That will happen on this testing server. And then at that point, I'll be able to expose it and then, ask questions, ask it to reason about the data that I've tuned it on, and see if that, is a useful product at the end of the day that justifies, a serious investment on the part of my boss and his boss. The TLDR is, if you want something that's going to be competitive on a reasoning level with Claude or ChatGPT, you can certainly build that at home, but it's going to cost you 5 figures, at which point it would take you 5 to 10 years to pay that off and break even, probably. But that's if you want like full agentic, like the full weight of the hammer, you know what I mean? That being said, if you just want something to, similar to what I use it for, which is, write a 100-line Python script that does this, then takes that data, puts it in a particular format, saves it locally, or saves it remotely. You can do that on a 14 billion model very easily, and it's very accurate. It's fantastic, and it's fast, and you have a beefy context window to dump context and supplementary data into. That can totally be done, less than $500, which might be compelling for some people. I mean, before I built this, I had ChatGPT, the $20 a month subscription, and I had Claude, also $20 a month. That's $400 a year. If this were to replace, cloud LLM usage, it pays for itself in less than a year and a half, which is nice. But I also, there's also the other benefits of not having my data in the cloud for, OpenAI to monetize at a later time. So it really depends on what you want to get out of it as far as whether or not it's reasonable to do. You could build any of it. I've seen people on YouTube build rigs that can run the full DeepSeek 671 billion parameters. But that's an insane amount of money. It's large, it's loud as hell. You can't have it like under your TV in your entertainment center, right? But like I said, on the other end of the spectrum, if you just want very basic, relatively low level reasoning, then yeah, you can put that you can run that in a computer tower, and it's totally doable. So it really depends on what you want out of it. But if you want really anything beyond a 30B, well, and anything beyond multi-GPU, unless you're willing to spend a ton of money, you're gonna have to buy all data center cards, which means passively cooled, which means they have to be in a server, which means that server has to live in, I don't know, your climate controlled closet or your garage. And it just becomes this whole other thing. You have to, deal with networking to it, and all this other crap. So the trade-off falls off very quickly past, a single GPU with a 14 to 18 billion parameter model. That is what I found at the end of the day. That being said, it is pretty cool to run and see it run, and it's been a really fast learning experience, which is why I err on the side of building things myself and doing things myself, because I get really tired of reading, theoretical stuff. Well, I got this result, but I did it a slightly different way, and it's like, well, really want to know if my way can get there. And then at the end of the day, if it's successful, then I can build the real thing that's badass and useful to me and others at work, which is, mostly the end goal here. So I hope this video was useful, but otherwise, thank you for watching, and we'll see you next time.